Okay. Okay. I think welcome everyone to our panel 3, how to increase the research productivity and the impact of the imaging statistics. And how to move this stuff. Okay. And actually we have the 4 panel members, and I found Hernando, Anuj, Michele, and I'm the moderator. And actually, first I give you the culture and the practice of the statistics. Actually, I modified this one from David Donahou's sentences. He wrote something for me, okay, for GSM. And major developments in statistics often arise from significant drivers in the world of data. Okay, new data sets, new observation challenges. And with the growing scale of the big data and the technology advances, such as the computational softwares, hardwares, then e-commerce and biomedical sciences, the past 20 years have seen substantial progress in neuroimaging data analysis per se, such as large-scale data connections like UK Biobank, ABCD, and other studies, and the big data integration, and also study designs. That's very important these days, and the new algorithm methods like deep learning. And actually, many of the recent exciting development has occurred outside the traditional statistics, with the data science trend outside the statistics to meet these demands. Okay, and actually, computational neuroscience is not that bad. It's one of the several areas that has made important contributions due to many pioneers from our field, because we started early. Okay, but this is very important. Another very important thing is also came from David Donahoe, is about data work. A persistent complaint in the data science is that everyone wants to do the model work. Okay, nobody wants to do the data work. Okay, and yet the data work is essential and increasingly dominant. To be honest with you, most of the major breakthroughs and basically many come from the devices and the data work. Okay, and the data processing plays a crucial role in the development of various imaging analytical methods. Processing large imaging data sets is labor intensive in many aspects. For many statistics by statistical groups, rely on collaborators for this work can significantly hinder the research productivity across various domains. Okay, overemphasize on the method development can lead to practical and theoretical disconnections between the mindset of the young statisticians and the challenges they face. Okay, that's basically the 2 major things. It's so important for us to think about in the last 20 or even 40 years, what's happening in our field, what they are facing now. Okay, and actually, the first set of questions is about research impact. But you can pick 1 or 2 you think you can comfortable to answer. The first one, how much neuroscience knowledge citation should learn? But do we really learn all these knowledges in what degree? Or you just direct copy whatever my clever said, okay? Should we always use more complicated models for real data analysis? And 3 is, how can statisticians collaborate more effectively with domain experts in neuroscience to identify high impact problems that require statistical expertise and or innovation, and have real world applications and the real world impact? What criteria should the statistician use to prioritize neuroscience related problems, ensure their method address significant scientific and clinical challenges, and have the potential break impact? Tom, could you start from you? You got whatever you like to answer.
Now I understand why they left the seat empty. So I had to be the first person. I think I'll pick out the one, basically sort of how to choose your problems. Because actually, what I can relate is, and it's too bad Rob is not here, but I was at Carnegie Mellon when Rob had just made the decision to get involved in neuroscience. And so I actually sat in on some of the meetings. He basically sequentially, over the period of a year, met with neuroscientist after neuroscientist. Some people did PET imaging, some people did bench signal unit. That's what he ended up settling with. But it was really interesting watching him because he had this laser sense of like, where can I make an impact with good statistical methodology? So, for example, when he talked to the neuroimaging people doing human neuroimaging with PET, it's not that there weren't some statistical questions, but he didn't see, well, first of all, he didn't really see how that exactly linked to how the brain works, and he wanted that connection, but he couldn't see how his contributions could actually make a difference. And so to me, there's this weird thing because the world needs more statisticians, right? Not just like people don't have enough skill. The biologists don't biologically oriented people don't have enough statistical expertise. But if you're saying as a statistician who wants to make an impact on statistical science that's going to actually impact biology, you can actually be you could take it like Rob's approach, which was to say no to a bunch of people. He didn't blow up, but he had one meeting with probably a dozen people or more who he's like, nope, that's not, I can't, nope, can't help you, no, yeah, no. And then he found he found the monkey single unit recording people. And it's like, points on a line, point processes. Okay, that I can understand. I can actually, and seeing his work, from that to then when he presented SAMC to what he presented here was really incredible because he showed how modeling the variation lets you kind of deconvolve these things in time and get this sharper inference and really making an impact. So my question is, can we all be Rob Katz? And that's what I'm not sure. Is that can we say no to 12 people and then say yes to the 13th? But if you're trying to maximize your impact on statistical science, the answer is, well, then that should be your cost function. So,
but I personally feel you take a different, approach.
I know I haven't. I mean, I'm not as smart as Rob, but yeah, I've taken a different approach, which is trying to split the difference of I'm coming at it the same way, which is saying, taking relatively simple things and seeing how much of an impact they can make and trying to improve sort of the practice. I'm taking, I guess I meet the neurometers more where they are, they doing sort of maybe sloppy, not well controlled, not worrying about false positives, and then trying to bring in simple techniques that can improve that. I mean, that's where I started my career, sort of focusing on multiple tests.
Because I saw, because I think both Keith and you our real models have a big impact in your image in general. And I think your guys' approach is more like you're doing something for them, right? Your approach from this helping with the hypothesis testing, all these kind of things, then you gradually do increase your impact and do more other things. That's my observe. What do you do?
Yeah. Well, I was very lucky to be there at the beginning when there's low hanging fruit, when people were just not worrying about multiple testing at all, and just being, and also one of the reasons why they didn't one of the reasons why they were doing sloppy things is because they didn't have good techniques to deal with the problem. And so since the Bonferroni never showed them anything, they're like, well, I guess I'll just use 2.3 and look for blobs more than 4 voxels in size and then run with it. And then we were able to sort of improve what they could do, whether it was random field theory or permutation. Anyway, I've talked too much.
Yeah, keep going. I'm learning something.
Okay.
Also, I want to say something about item 1 and 3, maybe like collaboration. So, firstly, you have to play to your strength. If there are 12 people, potential collaborators, you have to sort of shortlist where you can actually contribute with some work, but you can't pick up a problem where you'll learn from the scratch and maybe in 10 years you'll contribute. So you can't do it. You have to play to your strength. The second thing is, of course, you want somebody who's an equal partner in some sense. You don't want somebody, I've worked with biologists, not as much as neuroimaging directly, but biologists of several types. So one guy I really liked was the guy who'd say, statistics and math and geometry are really important. He would say that before even I walked into the room. Before I convinced him of that, he was already convinced. And so it's not like he would just ship the data and say, send me the p-value back. He would actually sit and discuss day in, day out that this is what we want to do. This is already done in the field. This is what is missing in the field. So that's one thing he did. The second thing he did was, so I'm talking about the 3D genome, the shape of chromosomes, and so that field of work we did. Second thing was he was willing to take it and present it to that community in a way we could not do. You know, help us write papers, go to those conferences, even got grants in that field for our joint work. So you need somebody who's really excited and active partner. So that would be my way of selecting 1 out of 12. I don't have 12 options like that. Probably have 2 or 3, but you need an excited, equal partner, and in the field of your strength. So that's how I say.
So yes, I agree with everything that has been said so far, and I like to see all these questions as somehow inherently related. In general, so I like to think of us as stations as somehow bridges between what we do and different fields, right? So, for example, right, it's very easy for us to play in different fields, in different yards, right? But in order to play effectively, right, we have to know what's going on. So what I'm trying to say in this way is that we need to have some training, some understanding. We cannot just go naively into a field and pretend to know and to just impose our modeling, right? This is also important with respect to the second question. I'm always perplexed when I hear about complaints about complex models, because I think that the question is a bit ill-posed. The point should be thinking about if what we do, our methods, first solve problems, second are usable, and third, if we are able to explain easily what they do. I don't think that our biologists, neuroscientists are against complex methods per se. If you think about fMRI scanner, is not a simple machine, but it's easy for them to use. It solves problems, and at the end, it's actually very easy to explain what the machine does. And I think that's a bit what we should try to aim at. And so I see essentially also in this way, I hope that our journal, with respect to other journals that are more statistical in nature, will try to get us to think about these things and try to get us to a point where we're able to produce usable, easy to explain methods to the community.
To complement to what Michele just said, so Hongtu asked the question, posed the question about what importance do we place on data work, quote unquote. And data pre-processing is very, very important. But if we ask ourselves, why do not many people invest in that work? Is because it's a fault of our profession. It's the fault of it's our fault of our leaders, because we fail to reward people who work on that area. So how many data pre-processing papers could be accepted to JASA? Probably not very many. And so, because we look up to JASA, Analysis of Applied Stats, Analysis of Statistics, and these journals will probably never publish a paper on data pre-processing. I don't know. And so I think we are to be blamed partly for that failure. And in fact, one of the missions of this new journal, it's called Data Science and Statistics and Imaging. Data science is there, which includes data collection, data pre-processing, data modeling, software implementation, and so on. But it starts with data collection. And so papers that on imaging that focus on how do we improve data collection, experimental design, so we get very good results, clean results in the end. That's we will welcome this in the journal. How do we properly? How do we propose pre-processing methods that'll improve downstream analysis? Again, this will be welcome in the journal. So we have to find. So hopefully this will be a place where people who want to focus on data pre-processing and be rewarded for it and have papers that will count towards promotion or tenure. After all, this is under ASA. So hopefully this will provide a venue for such researchers.
So just to be controversial, I would say, so my perspective on pre-processing was always that, one reason why statisticians didn't do it, because a lot of it has very much engineering aspects. Like they try lots of different things and then find the thing that works. Or, rigid body registration, well, where's the statistical model on that? I mean, that's actually really hard because then you have to model.
I talked about it this morning.
Oh, you good. So I don't know. I mean, just to what do people? Someone tell me I'm wrong.
But then, actually, the other day mentioned the fact that depending on pre-processing, your inference is going to be affected, right? So this is what we are interested in, right? In trying to find ways in which you develop a pipeline that is not going to be eventually affecting your results downstream.
Even some experiment where this particular kind of pre-processing, this will lead to this different kinds of results. I think that will be something that is informative to the community. Also, I don't necessarily see the twiddling of the parameters, looking at which one gives you quote unquote optimal results, whatever your outcome of interest might be. I would not necessarily look down on that. I think it's all part of statistics, all optimization in the end.
I guess I can definitely think of cases where I have some ideas where I could use, statistical expertise to improve one part of a pipeline. But of course, by definition, pipelines is stringing together all these things. And it's hard to, if my students spent the time to do every one of the steps of the pipeline, they would never have any time to develop statistical models.
But I can give you an example from a computer vision community. So the data sets, when we were younger as scientists, data sets were very hard to come by in any field of imaging. And so computer vision community had this model where somebody who publishes a data set can be published as a paper. And I can tell you at the moment, those are the highest cited papers in the community.
But is that statistics?
Well, I think that I want to return to that question, because that's an important question.
What is
statistics? Yeah, what is statistics is something we can debate for a very long time. And there was a point that a lot of good things had come out from outside statistics. So one should not look, but just to return to this point about we should allow, curated data sets and publication, and in some way for them to be rewarded for that. And the way the other communities are doing that is by giving them citations and serious citations. And then that adds to their credibility in some sense. So I just wanted to answer that part of the question.
I think thanks all the panel members. And actually, what we did in JASA, or also LS, we do the same thing. Essentially, you can look at the recent, we post the guidance to all the reviewers and AEs. We have specific state. We have 2 channels. One is the regular JASA ACS submissions, 35 pages. And actually, we have short communication, 25 pages. The 25 pages is targeted for all these data analysis papers. You have to be very good, okay? And also you have the data processing pipelines. If you develop some pipelines, you think that will make a big impact. We'll also publish in JASA and LS and also in a new journal, okay? I think we try to change the cultures in statistics to appreciate more about the data pre-processing. And then you think about the last decade, in this data science, it's most of the starting points, there are 2 starting points, right? Most important contribution, one is Feifei's ImageNet, okay? She just, recruited 2 graduate students from Princeton, basically do all these dirty work from the beginning to end, right? And using all kinds of engineering skills to make that happen. But actually, that's not making the Feifei stand out as one of the pioneers in data science these days. Okay. And it doesn't mean that the modeling, deep learning itself, also important. The both basically, the mainly, you see that they actually these ideas basically to annotate the data, accumulate a large number of the observations and annotate the data, become a golden standard at least in the industry. Actually, industries for all these projects, include ChatGPT, they annotate a lot. Otherwise, the product cannot reach the levels the regular customer can use, because that's very substantial for any modeling. That's the reason I talk with any friends from tech, because I worked in tech for 3 years. But be honest with you, for any project, we do subcontract outside or do by ourselves, okay? And actually for internal, we put almost 80% of the budget on annotating the data, okay? And we just spend almost 20% of the effort just to train our model and use it in practice. It's great that you can achieve high accuracy. But if you subcontract to other companies, they don't have the data, they don't have annotated the data, the performance is horrible. Regardless of how smart you are, you are a top program, top research in that field, it doesn't matter, because the data is critical. That's the reason then the data itself, how to annotate the data, is critical for current stage of data science.
A very good example is audio versus video, speech versus visual. I mean, the speech processing has been working for so long. I mean, if you talk to NSF program managers, the computer vision guys will say, why can't we do what speech guys can do? The speech data sets were standard for a long time. 70s, 80s, they had lots of audio recordings, and you could analyze it, you can understand it. So speech processing, speech understanding, speech generation is a decade or 2 decades ahead of video data processing. But video data processing has come into or because of the imaging data sets, they started coming together, different kinds, and there are some classical names. But that was one of the missing link, is availability of data. And so it may not be statistics, but if it can facilitate statistics and give us a jump start, give all the glory time. I mean, it's a big contribution.
I think annotated itself is statistics, because you can using different method to optimize the cost. And also you optimize some of the specific metric, okay? Because that's also a statistical problems. You can minimize the cost, right? And also you increase all the efficiency, other things downstream. That's the reason these days, how to develop statistical methodologies to optimize data annotation is become extremely important in tech companies. There's some startup. Maybe you some know the guy from MIT. He's the second year. He quit the things. He has a new company. Is mainly develop tools for data annotation. They basically subcontract all the different companies, tech companies. I can use maybe 10% of the price. If you do it by yourself, I just do 10% of the price. Basically, do it for you. They have all these pipelines method ready to do different annotation tasks. That's the basic important. Okay.
Can you give me an example of an annotation task that would really help us and advance the field? Because I think my sense is that statisticians are most needed in areas where basically there's the signal is buried in the noise. And so you're going to tell me that some human is going to, reliably find that thing to then help.
I think I can give you
an example.
I'll give you several examples. Number one is segmentation.
Sure.
Yeah. Number two is imaging registration. Okay. Because I think the segmentation is critically important. And one big problem in the neuroscience in general, all these segmentations have some issues. Because of the generalizability and other things, because one of the key limitations is we don't have the human annotated the segmentation data sets. If we could have it, that would make the whole field move much better than before. right now. I think that's one of the key barriers in the field.
But I would say, I feel like the engineers are on top of this. I mean, it seems like every Mackay has a contest where someone has, annotated a bunch of tumor images and, I don't know, I feel like let's stay in our lane.
No, that's
I
not
gotta be
that
controversial.
No, that's not that easy because because of the simple annotations, okay, because you can clearly see the boundaries. That's basically you can computerize, automate it using some tools to do it because you see clear boundaries. But actually, for the tumor, it's much harder. In particular, that's the basically behind the tumor. Well, how do you see it? In what sense?
And I will tell you that you'll get, 3 different raters, you'll get 3 different segmentations.
That's another issue. That's one of the reason you see that basically the drawn or drawn and also self-driving cars move much faster in the last 5 years. One of the key reasons, because for most of the scenarios, they can annotate the data. They use the manpower to annotate most of the cases, and also they can simulate the data. Because you think about it, the car on the road is pretty simple scenario.
So what you need is you need to have a hospital full of doctors who stop treating patients and just annotate data, and then we'll actually start advancing.
No, I think I think
Then we'll get somewhere. You got it. Okay.
I think because one of the key difficulties for formatting images, for many cases, you didn't see the clear boundaries, and also
Hard.
yeah, I know
I
that.
don't know.
That's the reason the whole field is not moving that fast. Okay, I think that's one of the key problems for things. And also, you think about it, for many complex disease, nobody knows ground truth for complex case. Yeah, because also you feel that the scenarios because for our situation, the things is very complicated. Nobody knows the ground truth.
So I guess what I'm saying is we should be trying to think about what is an example of a benchmark thing where we have a prayer of actually getting to some annotation that we trust. So I'll just come up with something. Causality. That's like one of the things that's one of the most difficult things. Now, some people are doing things with TMS, where you actually alter brain, function. Is there some benchmark thing? And probably anyone who knows something about TMS probably says I'm full of crap and that's not that easy, but I don't know. You see what I'm saying? Like, I feel like we need to find some cases which are not just, engineering that I think where we actually could make a difference.
I think that is like causality is fundamentally important because at the end of the day, you think about translation of all these kinds of imaging biomarkers to all these different diseases. Because I think one of the problems could be we don't have the right tools to looking to find the right signals. That's
Well,
could be the reason.
Here's a fun game. I wonder if you could do it. I wonder if you could go into the UK biobanks or some gigantic pool and filter it down in different ways to create synthetic causal dependencies. Does that make sense? So, for example, sometimes my friend who's a geneticist said, like, "Oh, you ever want to test your method? Well, just find a loci where where half the people have this one variant, the other people do, and then just synthetically add an effect." And that's really cool because so all the people who are homozygotes for this get this this level of dose, and then in your data you add it in, and the other ones don't. And now you've added an effect that's actually going to have genetic dependence in it because of the dependence in the genome, and yet it's synthetic data. The United answer. You've just induced a signal. So I don't know. I'm not, but that's one idea is like let's to actually in some sort of naturalistic way sort of sift data until there is a true causal structure that you know and understand, and then try to find it. I don't know, just BS here.
Yeah, I think that's the reason last time I went cardiovascular disease type of the conferences. There are a lot of biologists there basically to do experiments. You can use animal models. There's a different animal model to do these kinds of things, right? You can also what is the Jason Stein do? Okay, he I don't know exactly tell the technology he used, but he's using like the cell type of things and to do this kind instead of you directly using the animal models, because anything you identify at animal models is still harder to transfer to the humans because another complexity behind it. I think if you're using some dry cell or something like that, then basically they generate something. That's
But what we're
some
getting,
project.
what we're getting around is it's really hard to get hard truth in humans.
Yeah.
That's the base.
But in generally, I personally, my opinion is how much neuroscience knowledge that you should learn. My personal field, not that much. This depends on how many projects you're working on. My personal, how do I learn? Because what I did is I wrote on many grants for my collaborators. I try my best to understand the science. What I did is anything I don't understand, ask them to explain to me. I don't read any notebook, okay, any books, okay? That's how do I learn. And second thing you can learn is you can go to the ChatGPT to ask, okay?
I think my strategy for students is to basically become drinking buddies with neuroscientists. I mean that's how I learned a lot.
And the third tool is basically you basically send one student to collaborate with somebody and do the project, a simple project for them, and they gradually accumulate that knowledge. That's another way to do. That's another way. How do I have good friends from neuroscience? Is I send my student there for free. Okay, I just say just tell my this student, give me some simple project to work on, write some paper. Ask this guy to do some big project for you. I pay the cost. If there's somebody really good at neuroscience, I want to get involved in that field, I send my student to them. I want to understand the simple things. What kind of project they care about it.
Hongtu, most of your examples apply only to you. Let's talk about poor people here.
Number 2.
This one?
I think we sorted this.
Yeah, the second question is basically, I think my personal suggestion to all the people is, I don't feel a complicated model is necessary. And for most of the larger scale data set we are working on, like UK Bank, all these things, and you don't, I think if you at the beginning, you use very complicated models, computation almost impossible. You just try to run some simple model to see the effects, try to understand the results, then go back to ask yourself whether I need to do something or not. It depends on how much reward you get. If you don't have any reward, I modify, make it complicated. They increase the 10 times my cost. Why should I do it? Okay, that's my style of doing things. I'm not just at the beginning, I just choose very fancy model. I don't. I choose a relatively simple model, straightforward, computation efficient. See what's happening. Whether my friends can interpret my findings in what sense. Then I think about it. I'll give you an example. Recently, I asked my student to do the X chromosome data analysis. I find a collaborator from University of Toronto, statistics. She's pretty good at that. And then I just use UK Bank. I ran X chromosome, all these major methods on the data set. And we dig inside all the statistical details and the final findings. And at the end, my student said, all these methods are crap, okay? But we still can write good papers and submit it, okay? And the reviewer is pretty happy with that. But my student is able to say that, identify several key statistical limitations and the problems. That's how do I sometimes pick the problem to work on. It's not a basic, we take the existing method, apply to the data set, see what's going on with that. Anything we can do better, much better. If it's a small improvement, I want to do, ask my student to do it with the resources. If you think of something, you think that's the big limitation, we can work out something, and actually I will encourage my student to do it. That's how I do project this thing.
I would agree that you don't want to do an epsilon improvement, but I would dare to say that probably among us, right, I don't think any of us has simple models in many different ways. So I think that the type of models we've seen these days are in different ways complex, right? And so again, probably the difficult part is then in terms of impact to go and be able to make them usable and to show people that actually these models solve different problems, right? I go back again to my previous point. So the complexity is typically in the eyes of the people that look at it, right? But it's important to make the what we do usable. I think that's and indeed make a step forward. And it is as you said, it doesn't have to be a simple epsilon step forward, but we've seen in, for example, the sliding window approach do not work, right? We've seen the multi-step approaches do not work. So of course, when try to solve these points, you're gonna go to more complex models, and it will be our task to make them usable.
Yeah, and if you have really complex models, you may make something that's really good and very accurate and tells you a lot, but they're not very practical to run. You can then try to find simpler things that do almost as well as that. And that's actually the work I did with Jan Kang and his thesis. Is like a crazy complicated analysis method for meta-analysis. And I'm really proud of that work, but has anyone ever run that? We did have one more paper with Tor, right? He used that. But aside from that, it's a very complicated model. But now I try to, do simpler things that get nearly as good at that. But now I have something to reference to.
Yeah, I think another thing is important is, and these days when we pick a problem to work on it, I think we wanted that the paper have a big impact, because usually we not think about from statistical perspective. We think about basically, you think I have this problem people care about. The people from the domain, neuroscience, they care about the problems. I read many of the Tom's papers, see how do you work on the different directions, right? You're not purely work on statistics. I think every year you only maybe publish 1 or 2 papers closely related to statistics, but most your other papers are not related to statistics. Like some of your the 2020 paper in Nature, that's about evaluating function from the pipelines, right? I think that all these things are important, because that's the reason these days I'm not just to say I'm purely, do all the statistical project. Actually, I'm looking for some big problems people care, and also as a statistician, I can contribute. That's something. How do I pick up the problem? Now, then also another things. If I don't have the data, I will never do it. Okay, that's basically the key questions you think about it. Basically, when we do all these projects, and you need to start with some problems. It's important. People care about it. The second is you have the data. Okay, if you don't have the data, we go nowhere, right? Then you cannot do too much. Okay, and actually the second question about the research product activities. Actually, I need to modify these questions. I find it the most straightforward, way to ask. Okay, and I think people care, in particular junior faculties, care about how to publish more impactful papers in top journals. That's number 1 question. Number 2 question: how to write proposals to get all funded, and either from the industry or from the federal government. And that's the most important 2 questions. Okay. This don't look at this. Just answer these 2 questions for the junior faculty.
So I'm going to start. When I was a junior faculty, even a postdoc, I think with Wolf Hernando, and we were writing some paper, and the question came up: where should we publish it? And he said very simply, publish it where people will read it and benefit from it. That was a simple suggestion, but it's not easy to answer that question. But I have seldom published in statistics journals, and I'm very grateful to the senior professors in my department at that time who let me do it. The impact comes from where somebody would download the paper or the code and use it. And one can measure it in terms of impact factors of the journal. And even if somebody complained, I would show them, JASA, NLS, and this is the impact factor. And I used to publish in IEEE. The IEEE would be 10 or 15 or 100 times more impact factor. And I say, well, that's why I do it. But I think that's where one should go, is where somebody will read it and use it.
But you didn't answer my question: how can you publish that many papers?
How to do what?
How many? That many papers. as many papers as possible. The number of papers you publish is also pretty large, right?
How to publish large number of papers?
That's the first, the definitely
Paul
about.
Thompson and
I will say,
Calhoun.
let me just finish my thought. I'll mention what my other advisor said. Michael Miller is like, what are you doing for nights nowadays? You work at night. Go ahead, sorry.
Oh, that's a good suggestion.
I think it's just very well. It's hard to know, what papers are going to be most impactful. But I just echo what you said, which is having the software. But it takes time, right? And to develop software that's easy to use. I mean, for a while, I was very lucky. 15, 20 years ago, basically everyone used one of 2 or 3 packages, and so it's easy to get my work in there by adding it to those packages. Now, especially with resting state and diffusion, I mean, there's just lots of different packages out there. So I think if you're lucky that you're in a field where a lot of people are using a certain platform, then certainly building things for that platform can be a way to maximize your impact.
How could you publish more than 20 papers per year? And also, some of them are published in very top journal like Nature or these kind of journals. How could you make it happen?
I would have to get divorced and fire my kids, and
I don't
change
think
my
that's the
lifestyle
truth.
dramatically.
That's the truth.
Nobody wants to go with this one. Well, it's a difficult question. I think that I still think that it is important to do what one likes to do at the end. But it is also important to understand that, and this somehow connects also to the previous question. I think we need somehow to change the culture, I guess, in our field, whereby, I mean, especially I think this is even more a problem in Europe than in the US. In Europe, typically 2 or 3 people on a paper, and people start a bit like, not being happy, right? Whereas in the US, there's probably now a bit more of a culture of a team of people, a group of people that works. So, and also when you look at, tenure cases, right? You typically look at the numbers, but also you look at what's the position of the author. And I think that probably we need somehow to think a bit out of the box, a bit more like what is needed now for not only productivity in our field, but also to progress the field. We actually need to work more in teams, and the recognition of a statistician may not be the one that basically does everything from the start to the end, but it may be just one person in a big group, and repeated type of involvements like this may actually be enough eventually to get someone to the tenure, I think, right? And so similarly for grants, I think it's going to be a group, I think. So it's somehow changing the culture in a way that, however, allows us to anyway evaluate people at the same time. So it's not that easy, I think.
Well, I have nothing much to add other than when I became a faculty in 1999, the culture was still very different than now, but things were changing. So prior to that, unless you publish in statistical journals, your contributions are somehow underappreciated. But then around that time, there was a surge of stats methods in neuroimaging, in biology. And so I was in departments that had senior people, probably some of them, but had an appreciation for the impact of statistics in neuroscience and biology and so on. So I was just very lucky. And around that time, there was a change in the culture where as long as you write a stats paper in a non-traditional stats journal like neuroimage, human brain mapping. So for neuroimage, I think there's a bit of a change now. I don't know though what's going on, but maybe Tom and Mark can speak more about it. Okay, so that's the, yeah. So as long as you're writing stats papers that are making an impact, they don't have to be deep in asymptotic theory. They don't have to be deep in complexity, as long as they have the potential for being used, for being appreciated by users because of their simplicity, their power, explainability, and so on. That's good enough. So.
If I can add one thing, I think I'll say that it is very important that when a junior investigator starts and goes into deciding what they want to do, they are starting to think about a research path, right? It's not only, I work on this project and the other project. There should be somehow, I think, a sort of long thread motivations, and this is probably what one can try to evaluate eventually. Are you really doing a path forward, different types of, different goals? A goal, I mean, this is typical for a biologist who never think about working on different projects, right? They have their hypotheses and their goals that they want to go to eventually, and this should be probably similar also for us.
Yeah, I think I give two extreme examples, and both are my friends, or maybe also Tom's friends. One is the Paul Thompson. How many papers do you think Paul has?
One a day, I think it was.
And he has more than 1,500 papers, and his H index more than 120, something like that. Another friend is also from medical imaging. Now he's in China, Ding Ganshen, and he also more than 1,000 papers. H index also more than 120. Okay, and this they if you look at their career paths, okay, they work extremely hard. That's number one, and also they extremely productive, and also they are very open-minded. That's important. They are not just looking at work on one problems. They used to work on, like Dinga used to work on imaging registration. He's well known for doing imaging registration, hammer stuff. Okay. Paul also used very slow, right? Paul has a background in mathematics and more on the different things. And they focus at the beginning, they always work on one hard problems. But if you think about it in the middle of the career, the move, kinds of the work on more problems and become more productive. I think
just don't know
you
what-
maybe have the same.
I'm not sure it's worth focusing on outliers like that. I mean, I think there's them, and then there's the rest of us, and
But I think you also have the similar task, like them.
I don't publish a paper a day.
No, they sort of a day. You're also productive. Yeah.
Day is not over yet.
Got one, it's coming.
Yeah. No, I think you don't have to publish, so many papers, but I think you need to publish, high quality papers. That's the most important part. We do this thing.
I think at some point we should also think that science is not just about publishing papers,
Yes.
it's about having ideas. And at some point, it's probably better. The problem is not, it's very difficult for the young people, but from the elderly like me, publishing one good paper is much better than publishing 10 incremental papers. So actually focusing on the number of papers is something which is, I think, really wrong.
I
Focus on good papers.
completely agree with you. But it's not that I'm not agree. I just give you examples. And also you think about this way. I'm not saying both their citation is very high, and because they have a handful number of highly citation papers for both of my friends. And also I can see their career path. Okay. They keep on, they are very open-minded. They solve many problems, hard problems. Okay. Then also they recruit a lot of good students, the postdoc to work with them. And actually they're willing to invest a lot of time on hard problems. They put multiple students or postdocs basically work on one challenge problems. They work from the data, from the raw problems. You think about what is how did form this enigma? What's the purpose of he form an enigma instead of just do everything by himself? What do you think?
Enigma is it's setting us a culture of data sharing to get people to give up their data. It's not about methodology. I mean, that's for sure. I mean, Enigma, if people aren't aware, Enigma is a consortium for meta-analysis and imaging. The initial one was for imaging genetics, where of course you were desperate to get enough data just to get into beyond 1,000. But now it's basically like a franchise. So if you went up to Paul Thompson, is like, I'm curious about people whose thumb bends the wrong way. It's like, sure, you can find some data across there, and he'll put you in charge of finding all the data for all the people, for imaging data for some particular variant, and then you will start a new imaging, a new Enigma working group for people with bendy thumbs or something. That's what Enigma is, and it's great. Now, it's certainly a platform to help. Maybe you'll develop the more improved methodology, but by and large, Enigma is a social thing to get people to actually give up their data and share it, outside of their group, to then get to some sensible ends to get results that we might be able to trust.
Well, I think that's how Paul think of that way. And I think another thing is important because for imaging genetics at the beginning, because the sample size is small, right? For genetic stuff, we always need a larger sample size. How conquer these kinds of barriers, how to solve that problems, to make a big impact. Only thing that's that he used the faster way he did. And actually for many these days, by bank, okay, there's another story behind. Okay. And these days there's a lot of consortiums in medical science. Okay. One of the key kinds of motivation is people work together, standardize some specific protocols. Okay. Like include the imaging analysis. Okay. And standardize because for many neuroscience lab, each lab has its own way to process the data. They basically form these consortiums in order to share the experiences, share the ideas, and they share the resources. And this is very important. This is in particular for the small lab. They don't have enough experiences. They don't have enough resources. They help them grow much faster. You see that it's not, you think about it these days, being a faculty is not your work as your own. You need to think about how to learn from the big people around the table on the stage. Okay, it's very important. Okay, you need to grow much faster. It's not instead of stay home. That's one of the suggestions. I give the two examples. You guys just will discuss that aspect.
I think we're having fun. I'm not sure if the audience is. So when
Any people in the audience want to ask?
weren't we supposed to stop 15 minutes ago?
Yeah.
You can ask questions because that's important for your career.
Is one thing I want to add before we get there is this journal. I think that's a great opportunity, and I thank you guys for putting in the effort. It's a great opportunity, and challenges are there with the opportunity. It's called imaging science, and Hernando, hit it right on the nail where it's not just neuroimaging. It's one of the things that, when I was section chair of this imaging section, I kept on saying people that we have this conference, annual conference, 90% of the people, speakers and the audience is from neuroimaging. Neuroimaging in the world of imaging statistics is a very small set. In the world of imaging data, here is your opportunity to influence the world, not just a part of the world. So, the reason we have this is we got rejected in other places simply because either this is not imaging, this is not statistics, this is not our kind of statistics. Be open-minded and be inclusive, and you will flourish. Imaging is the largest source of data in our society currently.
Our scope is beyond neuroimaging, as you mentioned. It's forensic statistics, solar imaging, astrophysics, remote sensing. What else?
The biggest source of imaging data in our society is this.
Yes.
That's the biggest source of imaging data.
Our scope is quite open, so yes,
Right.
indeed.
And also
Technology is huge.
our first paper is going to be on solar imaging, actually. And then secondly is when you're asked to serve as a referee or as an associate editor, then please consider that service.
Okay, we move back to the questions. That's the most important question for you guys. Okay, hope you understand some of the key points. Okay.
You're being told to wrap.
You are at time.
30 seconds.
I think there's another basically for us, for most of these junior faculties, instead of just writing papers, there's some materials you need to prepare it. The first one is how to get a high quality data set, how to process them. Are you dependent on other people or something else? Any question? Any suggestions?
Other people.
Hongtu.
All the previous answers.
Speed round.
There's other people, so.
Yeah, there we go.
Correct.
Oh, you
No,
need that.
Jokes apart, I mean, there are also repositories, and probably we should do a bit better. We actually were talking with Hernando about that earlier today, and so maybe you can, if you want, expand a bit. But yes, so adequately for me, in small groups, I think it's easier to rely on collaborators. But if there were some repositories that were available that actually were usable as well in a friendly way, and probably this is something that we have to think about, either see and do a review of what's around that maybe we can suggest, recommend, or maybe see there is the need for something different. But in that case, we will need importantly people to maintain, to create and maintain the repository, because the main issue typically is maintenance.
I wonder if there's anything we can do as a section to support this section on imaging. Well, don't say no right away, because maybe we have to push a little bit harder to get it done. Because one of the challenges is that, you know, when we propose new methods, we're asked to compare it with existing methods. And what do? We simulate data, and then we're asked to compare with another existing method. Now, these people may not have may not have their codes available, and so that's an extra layer of challenge. But if everybody will have a standardized, okay, these are the set of images or set of data where we can all use to compare different methods, the pros and cons of each and every one of them, then there's a way to really standardize, instead of saying, okay, I'm gonna run a simulation, and we all know what we do in simulations. Okay, so I think having real data in there, I think that would be a much better way of setting up.
How to,
There's an easier solution. Reviewers should stop asking people to compare their methods all the time. Like
that's a great point.
It's a lazy reviewer thing to do. You say, go ahead, compare it to, you haven't compared it to the state of the art. Then what do? You go west a week.
Well, but if your method is worse than state of the art, or doesn't do anything
No, but
different.
the state of the art has a zillion parameters that you can adjust and tweak until you get what you want. So it's kind of nonsense. We're wasting each other's time.
how to
My
discourage these the two editors? They are too optimistic.
Well, I think having benchmarks is great, but one of the challenges is that there's so many different questions. I mean, you work in MEG, EG, I mean, there's resting state, task, and so I mean, I think it's a great idea, but I think, if Lexin isn't here, but I mean, you gotta start somewhere, and where are you gonna start? And then, you know.
No, I think the
Somewhere.
no, I think the problem is there's privacy issues, like you can bank, you cannot share even process the data. But there's legally, you're not allowed you to share any of these like medical imaging data from your donor age, even your process it. If you share all the data, you will get fired. Okay, to be honest with you, I can tell you how do I find the data set. Okay, number one, there's the two major resources these days. One is MH and the data archives. They have all these data. They try to assemble all these data, thousands of data sets together and put it over there. The only things, whether you want to do analyze it, you can start with one simple ones, small ones, and to build the protocols, pipelines to do it. Okay. Another one is AIA. AIA invests tons of resources to assemble imaging, genetics, all kinds of the clinical behavior, all these data set, and put it together and as data archives. To be honest with you, because all these existing biobank scale data sets, you're talking about gigabytes. We don't have money. You don't have money too. You don't have resources. ASA don't have a penny. Okay, if you ask me, Jasa, to create a data repository, tell you, I don't say anything. They will say who paid the money. Okay, don't That's the two things. Another sources is great is all these dream challenges. You go to medical dream challenges, and the CBTR also organize some dream challenges. For this data set, the organizers spend a lot of time to create the data set is clinically meaningful, practically useful, and for people to use. Then, and also they have a testing data set. You have a training data set, they have a testing data set. That's also another great resources. That's my personal feel that these three resources are most commonly used. Another one you can use is just to find local collaborators. Okay. That's the new data type. You want to do it? Okay. We'll just stop here. Okay.
Yes.
Thank you.